All right, so this is the final part of this section when it comes to it. So properties of the trig functions, and it's going back to the triangles and the circles we talked about at the very beginning as well, right? Using these portions, and we also talked about in the last section, is, well, what if I give you less information and ask you for the same exact thing? So find the exact value of the other trig functions given very basic information. Okay? Now, when it comes to these kind of stuff, we have to figure out two different things, right? Given us, so for example, they give us very little information, asking for the other four portions, right? Now, from here, what's given to us is the actual circle itself. So if we draw a circle, okay, and going back, well, we got to remember what was corresponding to sine. So sine was actually the y component over the x component, or over the r, the radius. So we know that the y component is going to be 1, and the radius is going to be 3. But here's the problem. The y component, where it's positive, is here, which means I can have two different things happening. I can have it the point here or the point there. Because again, this guarantees me the y component to be 1. It's both positive. Right? And this is going to be 3, and this is going to be 3. The question now is, which one is actually going to be the one we want? Well, that corresponds to what's given it to us here. So it says cosine theta is less than 0. And we know cosine theta is x over r. And since the radius can never be negative, therefore it forces the x component to be negative. Which means if it's negative, well, when is the x variable negative on this side? Which means we can cross the shade out and know that this is going to be our true triangle we're actually be dealing with there. And now we can regenerate ourselves to find the x value itself. Now this time that we know what r is, it's 3 squared. We know what y is, and we're trying to figure out what x squared is. So corresponding here, that's going to be 9 plus 1 plus x squared. Subtracting gives you 8. So the x value is going to be negative 2 radical 2 if you simplify the radical. Again, it's negative because we know it's going to be the negative component. So it's going to be minus 2 radical 2 on that side. Okay. And now from there, we can generate the other 6 corresponding portions. And again, let's say 5 because of that portion. So for instance, right, so now cosine theta will be 2 radical 2 over r, which is 3, and just go down the list from there. Okay. Same thing we did in the last section. Okay. So let's try B, the same exact concept. Okay. So this one says cotangent theta is 4 over 3, and cosine theta is also negative as the last one. Okay, well, again, we got to go back and what's cotangent, right? So cotangent is x over y. So cotangent theta is x over y. Right? So therefore, we have 2 points happening. We can have 4 over 3, right? Because that's x over y. Now here's the thing. We can also have another component. We can have negative 4 and negative 3. Because if we divide them, that also gives us a positive. So again, just like the last one, we have 2 different points to choose from. Whether they're both positive or both negative. So the question again now becomes, which one's going to be the correct one? Okay. And again, from here, corresponds to our second situation given to us there. Again, since cosine is negative, and again, we know that from our last example, r can never be negative, so therefore the x component must be negative. Well, which one of these situations is the x component negative? That one. So therefore we know our true triangle is going to be in quadrant 3, this one down here, where this is now going to be negative 4, and this is going to be negative 3 for your x and y coordinate. And now we can find r associated. So we have negative 4 squared gives you 16, negative 3 squared gives you 9, that's going to be 25, so r is going to be equal to 5. And again, from there, now we can find the other 5 trig functions. So I'll just start you guys off. So cosine theta is going to be x over r, so your x component is negative 4 over your r, which is 5. And again, now we do the other 5, right? Tangent, cotangent, based off these 3 values now. Okay. So why don't you guys try that C and D, a little example we did, use a template for these two. So I'll give a quick pause. 3, 2, 1, pause. Okay, so hopefully you guys try them, see what let's try them together when it comes to it. Okay. All right, so secant theta. So secant theta is r over x. Okay, so this is the same r over x. Okay, now we have a negative 2. So what this saying is this is negative 2 over 1, correct? Because I want it in fraction format. But again, the r cannot be negative, correct? R always has to be a positive value. So what this means is this is actually a 2 over a negative 1 value. So we know our x-coordinate must be negative. Okay? So therefore, the only way x is negative is in quadrant 2 and 3. So it depends, is it going to be here? Or again, going to be there, depending on what we have. So which triangle is it going to be, the top one or the bottom one? And now we look at the tangent portion. So since tangent is positive, right, this is greater than 0, again, we go back, what was tangent to begin with? So tangent is y over x. Okay? All right, so we know from our point, it's negative 1 comma something, right? We're going to find the y-coordinate when it comes to it. But if I plug in negative 1 into here, what's the only way, let's say, what sign can y be to make this all positive if we have a negative x? Well, negative and negative must make it positive. And in order to counterbalance that, y must also be a negative value. So since y has to be negative, make this both number positive, therefore, cross this one out, and makes both of them are negative in quadrant 3. So therefore, this is going to be negative, well, just bring it over here. Negative 1, this is a 2, and now we can solve for y going backwards again using Pythagoras theorem. So we have 2 squared is 4, plus negative 1 squared is 1, plus y squared. Well, this is 16. Just do it all quickly. Subtract the 1, that gives you 15. So y is equal to radical 15. No, actually, no, I already squared it, right? Sorry. This is 4, 1 plus y squared. Subtracting it, yeah. So y gives you radical 3. Sorry about that. Okay. So this is negative radical 3. Again, negative because we want the positive negative. And now from there, right, using the triangle, we can find the other ones. So I'll give you guys a quick one, right? Tangent of theta. Well, tangent is y over x, so y is negative radical 3 divided by negative 1, or just positive radical 3. Okay. And then from there, you just do the other 4, right? So the last one, D. Cosine theta is 3 over 5, and theta is in quadrant 4. So the good thing is, right, this is the easiest one since I told you where theta actually is. So there's not really too much, right? It's in quadrant 4, so it has to be here, no matter what. Right? So theta is x over r. So our x component is 3, our r component is 5. Now again, going Pythagoras theorem to find the y component. So we have 5 squared is 25, plus 3 squared is 9, plus y squared. Subtract it over should give you 16. So then y should give you 4. Now, we're going to use negative 4 because it's in quadrant 4, correct? That means the y component is going to be negative. Okay? And now from there, now we have used the other 5 functions, right? So sine theta is y over r. So negative 4 over 5. Tangent theta is y over x, so negative 4 over 3. And just do the other portions as well. Okay? So last little portion is a little tricky, right, when it comes to it, is basically the same situations as you did earlier when it comes to it. Instead of me giving you a point, now I give you conditions of very little portions and just regenerate the entire portion there. So a little bit of practice here when it comes to it, and you guys will get the hang of it.